Hello, welcome to Chapter 1, Closure for Core Connections Algebra. With this being the first one, there is some extra problems at the end of each chapter and gives you an opportunity to ask yourself, what have I learned? Most of the problems in this section represent typical problems found in this chapter. They serve as a gauge for you. You can use them to determine which types of problems you can do well and which types of problems you require further study and practice. We're going to solve each problem as completely as we can, and then at the end of the closure, there are the answers to the problems as well. The video obviously will help you just be able to go through the problems and see how to possibly do some of them. So we'll start with question 83. Use the order of operations to simplify each expression. So in part A, we have 5 minus 2 times 3 squared, which is 9. 5 minus 2 times 9 is 18. 5 minus 18 is negative 13. On B, negative 2 times negative 2 is 4. C, 18 divided by 3, we work from left to right with multiplication and division. 18 divided by 3 is 6. 6 times 3 is 36. On D, the difference between B and D is only the 2, since it's not in parentheses as being squared, so that answer is a negative 4 compared to B, which is a positive 4. E, 5 minus 3 is 2, so we're going to do inside the parentheses first. 5 plus 3 is 8. 8 times 2 is 16. F, I'm going to go in order because it is all multiplication straight across, so 24 times 24 is 576. Then we are going to multiply that by 1/4. And then kind of continue to work our way across. So 576 times 1/4 would be 144. We'll then take that and divide by negative 2. And then divide by negative 2 again. So 144 divided by 2 is 72. So it's negative 72. Divided by negative 2, and that would be 36. And then G asks, why are answers from part B and D different? Well, kind of just already talked about that. In part B, the base, which is what you are raising to the power of 2, is the quantity negative 2, whereas the base in the D is just the 2. So it's negative and then 2 times 2. So I just realized that the problem that shows up on mine, on F, looks to be different than what is in potentially your book. So what you might see in your book on F is 24 times 1/4 divided by negative 2, which you can see got a lot of extra numbers in there if this is the problem. So 24 times 1/4 would be 6, and then 6 divided by negative 2 would be negative 3. So if the F that I did is different than what you have in the book, it's probably this one down here, and then your answer would be, as I said, negative 3. Question 84, copy the pattern below onto graph paper. Draw the first and fifth figures on your paper. So let's go ahead and do that. In terms of the pattern, it looks like this tile was added, and then these two at the end. And so same thing on the next one, it looks like one tile was added, and then the 2 at the end. So it looks like 3 are being added each time. So if I take figure 2 and I work backward to figure 1, that means I would take this one off and then these two, because that's what would have been added. So figure 1 would look like this. So that would be figure 1. And then figure 5. Looks like we would have 4, because you'd add an extra 1. Still goes up and over. I just need to make sure I have enough here. So 1, 2, 3, 4, 5. So I believe it should look like that. So there's figure 1 and figure 5. How many tiles are in each figure? So figure 1, the total would be 5. Figure 2, you're adding 3, so that would be 8. Figure 3, you're adding 3 again, so 11. Figure 4, you added 3, which would be 14, and then figure 5, if you added 3 again, there should be 17. That's part A. Describe how the pattern is changing. So each figure has 3 more tiles than the one before it. And then question C, how many tiles would the 6th figure have? The 6th figure, if I added, you can see that I can just continue the pattern and add another 3. So figure 6, I don't have to draw it, but figure 6 would have 20 tiles. And then it wants us to go to the 10th figure. So 6th figure would equal 20 tiles. And then the 10th figure, we could just keep adding it up if we wanted to. So we could create a little chart here in terms of X representing the figure number. We already had 1 starting at 5. Now I didn't have to write from the very beginning because we know we're just adding 3 each time. But if we continue this, this is just one way that we could do this. And we just keep adding 3. And it looks like figure 10 would be 32 tiles. And as I said, that's one way to do it. It's definitely not the only way. Some of you might have created an equation and then plugged in 10. And the equation, if you chose to do that, would have been y equals, it's growing by 3, so it would have been 3x plus the original figure 1 would have been at 5, and then if you plug in 10, or not figure, sorry, you have to go back to figure 0, which would have been 3 less, so it would have been 2. There we go. So this would have been 3 times 10 plus 2. And then that would have been 32. So it still would have worked. And by the way, this represents figure 0. So a couple different ways you could have looked at that. Question 85 is the diamond question. It's done these a couple different times. Remember, on the top here, we're multiplying, and on the bottom, we're adding. So 9 times negative 9 is negative 81. 9 plus negative 9 is 0. On this one, we're looking for what two numbers multiply to give you negative 36, but then when you add them, you get 0. Well, think about that. The only time you can add two numbers and get 0 is if they're opposite each other. So we could use 5 and negative 5, but we also need numbers that multiply to give us 36 that are the same in terms of their number, but then opposite their sign. So what would that represent? That would give us negative 6 times positive 6 would be negative 36, and then negative 6 plus 6 would be 0. So 4 times what gives you negative 20? 4 times what gives you negative 20, and that would be negative 5. So we know over here that should be a negative 5, and then when you add them up, you get negative 1. On this one, we don't know the x value, so the question is 4/5 plus x is supposed to equal 1/2, and so we can subtract 4/5, 1/2 minus 4/5. You do need to find a common denominator, which would be 10. So 5/10 minus 8/10. So x would have to be negative 3/10. So negative 3/10, and then now you can multiply negative 3/10 times 4/5 to get the product. Could just multiply straight across and then reduce. So if you do that, you get negative 6 over 25 when you simplify. And so continue to work on those diamond questions. Given 2 pieces of information, you can always find the other 2. 86. Graph and fully describe the function y equals 2 times the square root of x minus 1 plus 3. So for this one, I would just rather use Desmos or a graphing calculator. Get the graph down. If you want to use a t-chart and plug everything in, that's perfectly fine. But the bigger question on this one is I want you to work on fully describing the function. So I used my graphing calculator. I only showed you the table of the x values that gave us integer y values, so not all the decimals, and I plotted those 4 points and I graphed it. So now we want to go and fully describe the graph. We need to talk about the shape, the intercepts, symmetry, is it a function? In this case, it actually tells you it's a function. Think about your domain and range. Are there any special points? Is the function increasing, decreasing? So think of all those possibilities. Think of all those graphing investigation questions we were looking at, and write all the information down to fully describe this graph. And so there's the list that I created describing the graph in all the different ways that we were talking about in the class. Question 87, solve each equation and check your solution. So on part A, we have 3x minus 1. I'm going to simplify as I write it. So 4x minus x is 3x plus 8. We're going to get the variable term on one side. And by doing that on this one, we actually get both terms to cancel out, and we're left with a statement that is not true. So that means no value of x will ever be able to solve this equation, and it is a no solution. On B, we have negative 10 plus 5x equals 7x minus 4. So I'm going to go ahead and subtract 7x. Negative 10 minus 2x equals negative 4. We then need to add 10 to get the variable term on the left, and in this case the constant on the right. Divide by negative 2, and x is equal to negative 3. Now, it does say check your solution. I'm not going to go ahead and check these on here, but remember to check them. You're plugging back into the original for x to make sure it's a true statement. C, we're going to combine 28 and 4, so that's 32 minus 6x is equal to 30 minus 3x, so I'll add 3x to both sides. 32 minus 3x equals, supposed to be a 30. And then we can subtract 32. So negative 3x is equal to negative 2. Divide by negative 3. We don't want to write this one as a decimal because it's a repeating decimal. So x is equal to 2/3. And then on D, 4x minus 1 is equal to, I'm going to combine these two, 9x minus 5x is 4x minus 1. And so when we subtract the 4x, once again it cancels out and leaves you with negative 1 is negative 1. But this is a true statement, unlike last time on A it was not true. So what does that mean for your values of x? It means that x can be all real numbers as solution. So x represents all real numbers. So x can be any of those values. You can pick any number for x and it will always work. Question 88. Find f of 4 for each function below. So remember, the 4 represents your input, and then the whole thing represents your output. So if I'm looking for f of 4 for part A, then we will plug in 4 into the function. And I'm not sure what is going on here. This isn't supposed to be there. So f of x equals the absolute value of x minus 7 plus 3. Once again, getting some extra stuff on these. I'm not sure why. So f of 4 is equal to the absolute value of x minus 7. So now it's 4 minus 7 plus 3. 4 minus 7 is negative 3. So the absolute value of negative 3 is 3. And 3 plus 3 is 6. So make sure you answer the question. F of 4 is equal to 6. 4 is the input. 6 is the output. Part B, f of 4 equals the square root of 4 plus 12 over 4. So 4 plus 12 is 16. The square root of 16 is 4. So 4 divided by 4 is 1. So f of 4 is equal to 1. And then on the next one, we have f of 4 is equal to 2 minus, now we have a cube root of 4 plus 23. So 2 minus the cube root of 27. So what number times itself 3 times gives you 27? And that would be 3. Remember, 3 times 3 times 3 is 27. So 2 minus 3 is negative 1. And that's what f of 4 is equal to. Question 89, evaluate each expression. So on part A, we have 2 divided by, need to do the grouping symbols first, so 3 minus 4 is negative 1. We get 2 divided by 1 because the absolute value of negative 1 is 1, and that would be equal to 2. On B, we have 11 times the absolute value of negative 6, which is 6. Then we need to do multiplication first, and then you can add those two together to get 81. C, we have negative 19 plus the cube root of negative 8. The cube root of negative 8 is negative 2 because negative 2 times negative 2 times negative 2 is equal to negative 8. Negative 19 plus negative 2 is negative 21. And then on D, negative 11 minus the square root of 16. Square root of 16 is 4. Negative 11 minus 4 is negative 15. And the last one, question 90. Use the function machine shown at the right to answer the following questions. If the input is negative 8, so we're going to take this and plug negative 8 in, what is the output? So for part A, we would say f of negative 8 is equal to negative 6 times negative 8 minus 3. So it would be a positive 48 minus 3, and that is 45. So f of negative 8 is equal to 45. That means the input is negative 8 and the output is 45. If the output was 21, what was the input? So now it's saying, okay, we don't know this. We know the output is 21. So we're going to replace the output with the number 21. So 21 is equal to negative 6x minus 3. We can add 3 to both sides to get 24 equals negative 6x divided by negative 6. And x is equal to negative 4 when the output is 21.